How do Leaky ReLU and ELU solve the Dying ReLU problem? Imagine a neuron in a neural network that suddenly stops learning because it gets stuck in a state where it no longer updates. That's what happens with the Dying ReLU problem. It's a common issue in deep learning where neurons stop activating when their inputs are negative. When this happens, the gradients, which are signals that tell the neuron how to improve, become zero. This means the neuron can't learn anymore and is effectively dead. This can slow down training or even cause the whole model to perform poorly. Leaky ReLU offers a simple fix. Instead of outputting 0 for all negative inputs, it allows a tiny, non-zero slope. Usually it outputs a small amount, like 0.1 times the input, when the input is negative. This small slope means the neuron still gets some gradient signals even when the input is negative. So the neuron keeps learning and doesn't get stuck. It's like giving the neuron a gentle nudge to stay active, even when it's in the negative zone. This way, the network remains more stable and learns faster. ELU, or exponential linear unit, takes a slightly different approach. For positive inputs, it acts just like ReLU, passing the input through. But for negative inputs, ELU outputs a smooth negative value that approaches a fixed negative number as the input gets more negative. This smooth curve helps the neuron produce meaningful negative outputs and gradients. Because the transition is gentle and continuous, it prevents abrupt zero gradients that cause neurons to die. ELU also helps the network train faster and more reliably because the gradients flow smoothly across the entire range of inputs. Both Leaky ReLU and ELU improve how neural networks learn by keeping neurons active and preventing them from dying. Leaky ReLU does this by giving negative inputs a small, fixed slope, ensuring gradients keep flowing. ELU creates a smooth, negative output for negative inputs, which also maintains gradient flow and stabilizes training. These functions are especially useful in deep learning models used in AI systems like ChatGPT, DALL, and Midjourney. They help these models learn complex patterns more effectively and produce better results. Using these activation functions makes neural networks more robust. They help avoid training failures and improve the overall performance of AI systems. This means more accurate text generation, clearer images, and smarter tools. In the end, Leaky ReLU and ELU are simple but powerful ways to keep neurons alive and learning, making AI models more reliable and efficient.